On January 2nd, 2013, Dubai opened a terminal for a single aircraft type. 11 floors, 20 gates, $3.2 billion. No airport in history had ever done this before. No airport has done it since. The aircraft was the Airbus A380. And the question worth asking is not why Dubai spent that kind of money. The question is what kind of airplane forces an entire city to make that decision in the first place. The problem was not the aircraft. The aircraft worked exactly as designed. The problem was with the world it landed in, a world built for a different kind of airplane and not fully ready for what the A380 demanded. This is the story of how one aircraft forced airports, air traffic systems, and ground crews across the planet to change the way they worked. Not because it failed, but because it was almost too large for the system built to support it. To understand why the A380 changed everything around it, you first have to understand what it actually was. The aircraft was 73 meters long, placed 2 tennis courts end to end, and you have roughly the same distance. The wingspan reached 80 meters from tip to tip, close to the full width of a standard football field. The tail stood 24 meters high. That is an 8-story building, sitting at the gate next to the terminal. At maximum takeoff weight, it reached 575 metric tons, the equivalent of lifting 1,500 cars off the ground at once. Every wide-body aircraft before the A380 carried passengers on a single deck. The Boeing 747 had a small upper section near the front. The A380 was entirely different. 2 full passenger decks running the complete length of the fuselage, from nose to tail. In its maximum certified configuration, it carried 853 passengers. The entire population of a small village, loaded onto a single aircraft, arriving at a single gate. And all of that had to move through an airport system that was never designed to receive it. But to understand why Airbus built something this large, you have to go back to where the idea began. By the 1990s, the world's busiest airports were running out of room. London Heathrow was operating close to its maximum capacity. Frankfurt, Tokyo Narita, and Singapore Changi were facing the same pressure. Passenger demand was rising. Flights were increasing. But building new runways was nearly impossible. Land near major cities was scarce. Costs were enormous. And regulatory approvals took decades. At the world's busiest airports, the answer to more capacity was, in most cases, simply no. Airbus saw that problem differently. If airports could not handle more flights, each flight would have to carry more people. The vision behind the A380 was built on that logic. The future of aviation would run through a small number of giant hub airports: London, Dubai, Singapore, Tokyo. Passengers from smaller cities would feed into these hubs, transfer onto large aircraft, and continue to their destinations. The A380 was designed to be the backbone of that system. But the vision carried a weakness. For it to work, the airports at the center of it had to be ready for an aircraft with an 80-meter wingspan and the capacity to deliver over 800 passengers to a single gate. The industry had not yet answered that question. The A380 was about to force it. Landing the A380 was not the hard part. The approach, the descent, the touchdown, all of that was manageable. The problem began the moment the aircraft left the runway and started moving through the airport. The A380 had a wingspan of 80 meters. When it turned on a taxiway, the wingtips swept through a wide arc. Within that arc were things that could not move: light poles, runway signs, service roads, other aircraft parked at nearby gates. Every turn had to be calculated. Every route through the airport had to be assessed. And at many airports, the existing layout simply did not provide enough clearance. Before the A380, the highest aircraft classification in the global airport planning system was Code E. The Boeing 747 sat in Code E. The A380 did not fit. So the International Civil Aviation Organization created a new one, Code F. A single aircraft had pushed the boundaries of the global classification system far enough that the system itself had to be expanded. Under Code F, runways needed to be at least 200 feet wide. The previous standard had been 150. Taxiways required a minimum width of 25 meters. Any airport that wanted to receive the A380 had to audit every meter of the path from runway to gate and rebuild whatever did not meet the new standard. Most airports chose not to. There are more than 40,000 airports in the world. Of those, Only around 140 were certified for regular A380 operations. More than 99% of the world's airports could not receive this aircraft. One aircraft had divided the world's airport infrastructure into two categories, those that rebuilt themselves to accommodate it, and everywhere else. Getting the A380 to the gate was one problem, getting passengers on and off it was another. The upper deck doors sat 8 meters above the ground, 3 meters higher than the doors on most other large passenger aircraft. At that height, wind forces on a jet bridge are significantly stronger. Engineers had to reinforce support columns and add stabilizers to prevent dangerous movement during boarding. And the A380 needed more than one bridge. The solution was multiple bridges connecting simultaneously, one to the upper deck and up to 2 on the main deck. But 3 bridges docking to one aircraft in close proximity created a new problem. They had to operate near each other without contact. An automated anti-collision system had to be developed specifically for this configuration. None of it had existed before. At John F. Kennedy International Airport in New York, the pressure became urgent in 2015. 4 airlines were planning A380 service, but only 2 gates could handle the aircraft. Airport managers had 8 months to solve the problem. A new gate was built at a cost of $3.7 million. During construction, crews discovered the actual building structure did not match the architectural drawings. Plans had to be rewritten on the spot. That was one gate at one airport. A report by the United States Government Accountability Office found that 18 American airports were making or planning infrastructure changes specifically for the A380. The total estimated cost was approximately $927 million. The Port Authority of New York and New Jersey alone spent an estimated $175 million on airfield upgrades. But no investment came close to what Dubai did. Dubai International Airport built an entirely new concourse from the ground up, designed around the A380 from the first drawing to the final bolt. Concourse A, 20 code F gates, 11 floors, $3.2 billion. The first terminal in the world built exclusively for a single aircraft type, the only one ever completed. When an A380 touched its gate, 90 minutes began. The aircraft had 16 doors. Only 3 were used for passengers. The remaining doors on the right side served one purpose, the ground operation that had to run while passengers were still moving through the terminal. Catering vehicles approached from the right. Cleaning teams split across both decks. Baggage loaders worked the cargo holds below. Fuel crews connected to the wings. Everything had to happen simultaneously. A typical flight required between 800 and 1,000 meals across 2 full decks. Existing catering trucks could reach the main deck doors. The upper deck was unreachable. New vehicles had to be designed and built specifically for that height. 40 cleaners deployed for every turnaround. 20 on the upper deck, 20 on the lower, working simultaneously. Cleaning completed in 35 minutes, but without direct catering access to the upper deck, the turnaround stretched to 126 minutes, too long for any viable schedule. With the dedicated upper deck catering door, 90 minutes became achievable. 1 delayed truck, 1 missed sequence, and the entire chain collapsed. But the most dangerous part of the A380 was not always visible. Sometimes it was the air it left behind. The International Civil Aviation Organization had always classified large aircraft as heavy. The Boeing 747, the Airbus A380, every major wide-body jet. But the wake produced by the A380 was so significantly stronger that a new category was necessary. The A380 became the world's first and only aircraft designated super. Following aircraft required greater separation, 6 nautical miles for heavy aircraft, 7 for medium, 8 for light. Every departure behind an A380 carried a mandatory wait of 3 to 4 minutes. But separation rules on paper are one thing. What happened over the Arabian Sea on January 7, 2017 was another. Emirates flight EK412 was cruising from Dubai to Sydney at 35,000 feet, approximately 630 nautical miles southeast of Muscat. 1,000 feet below, traveling in the opposite direction, was a Bombardier Challenger 604 operated by MHS Aviation, carrying 9 people. The 2 aircraft passed each other without incident. The A380 continued toward Sydney. Its crew saw nothing unusual. 1 minute later, The Challenger entered the wake. The business jet rolled violently through several complete revolutions. Both engines flamed out. The autopilot disconnected. Flight instruments failed simultaneously. The pilots could not determine the aircraft's orientation using instruments alone. One pilot later told investigators he used the color of the sky and the surface of the ocean through the cockpit windows to judge the aircraft's attitude and begin recovery. The Challenger dropped 10,000 feet before control was regained. 2 passengers were seriously injured. The aircraft was declared beyond economical repair and written off entirely. The crew made an emergency landing in Muscat. The A380 landed safely in Sydney. Its crew had no knowledge of what had occurred behind them. Aviation authorities worldwide issued updated guidance on A380 wake turbulence behavior. The invisible signature this aircraft left in the sky required the same careful management as everything it touched on the ground. That signature, and every challenge before it, pointed to a single question. Was there anywhere on the planet where the system was actually ready for this aircraft? There was one place. Within an 8-hour flight from Dubai International Airport lives more than 5 billion people. Europe, South Asia, Southeast Asia, East Africa, and Australia all fall within reach of a single departure. No other major hub sits at quite that intersection. Emirates built its entire airline around that geography, connecting passengers from hundreds of cities through a single hub onto long-haul flights worldwide. Of the 251 A380s ever built, Emirates purchased 123, 49% of the entire production run, bought by a single airline. The next largest customer was Singapore Airlines with 24. Lufthansa ordered 14. The gap was not close. Emirates did not simply buy the aircraft. It built a world around it. Concourse A, $3.2 billion, 20 Code F gates, 11 floors, every element designed for one aircraft type. At its peak, Emirates operated up to 8 A380 flights per day into London Heathrow alone. And it worked. The ground operation ran, the gates functioned, the connections cleared. In Dubai, with the right airport, the right airline, and the right route network aligned, the A380 did exactly what Airbus designed it to do. Where the system was built around it, the aircraft performed. Dubai proved the A380 could work. It also showed, without meaning to, just how rare those conditions actually were. While Dubai was building a world around the A380, the rest of the industry was moving in a different direction. The Boeing 787 Dreamliner, followed by the Airbus A350, carried between 250 and 300 passengers, roughly half the A380's capacity, but they could fly non-stop between cities with no hub connection, no Code F infrastructure, and no history of long-haul service. Any standard wide-body airport could receive them. The A380 needed everything to align: the right airports, the right route demand, the right ground operation at both ends. If any single condition was missing, the economics fell apart. The 787 and the A350 needed none of that. A route with enough demand and a standard airport. That description fit thousands of city pairs the A380 could never realistically serve. The retirements followed. Air France permanently withdrew its entire A380 fleet in 2020. Other carriers made similar decisions. The hub-and-spoke model the A380 was built to serve began losing its grip. The A380 had not become a worse aircraft. The system it depended on had simply stopped building itself around it. The Airbus A380 did not fail. The aircraft was not grounded because it could not fly. It was not retired because it was unsafe. Emirates, which purchased 123 A380s, continues to fly the aircraft today and plans to keep doing so until at least 2041. Passengers still choose it when given the option. What it could not do was change the world fast enough to match its own requirements. The world did change for the A380, just not enough of it. Aviation chose a different future, not because the A380 was wrong, but because flexibility proved more valuable than scale. And that choice revealed something that had always been true, even if it took an aircraft this large to make it impossible to ignore. Aviation is not powered by aircraft alone. It is powered by the runways beneath them, the taxiways they navigate, the gates that receive them, the ground crews that prepare them, and the air that flows behind them. Every one of those systems has limits, and when an aircraft arrives that pushes all of those limits at once, The question is never simply whether it can fly. The question is whether the world it lands in is ready to receive it. The A380 asked that question more loudly than any aircraft before it. In a few places, the answer was yes. In most of the world, it was not yet. And aviation, moving at the pace it moves, did not wait.